The most troublesome board in the Pioneer SX-1010 is the power supply. It literally tries to cook itself to death. As you can see, there's a lot of heat damage here. All of these components have taken a lot of heat stress. So we'll check the resistors, we'll upgrade the transistors, and we'll replace all the caps. We'll get some new thermal paste on there, and it should be ready to go. Alright, I have my replacement caps here. These are all listed in the BOM for Mouser that I posted in the description. And I think I have every cap I need, all the transistors I need. Soldering gun and soldering iron are on. Some pliers and some snippers. I'm going to set up so you guys can somewhat see what I'm doing, and we'll talk through the procedure. Alright, so I'm going to start by showing you guys what it looks like from this side of the board. What I'm doing now is I'm using the desoldering iron to remove as much solder as possible. These bigger caps, they actually have 3 prongs on the back. Only 2 connect, but there's an extra one for support because the caps are so big. They also have a little bit of glue on them, so you just want to go nice and steady. A lot of the leads are bent, so it's very easy to damage the board if you try to wiggle the cap while it's still connected. So make sure to get the ends bent back straight, and you'll see better once we flip the board here. But just pulling the old cap out, I'm going to wipe the board a little bit with some alcohol, try to get some of that old glue off, and at least saturate it with the solvent. And then I'm going to get this little small screwdriver and just kind of scrape away as much as possible. And this isn't as bad as I've seen. I've seen some of this glue really corrode the board and the parts, but this is just kind of just for aesthetics, just to get the old stuff off of there and start fresh. So we'll scrape this off of here, and I'll grab the replacement cap. It's a 470 microfarad 100-volt cap that's going to be the replacement, and it's going right in. The number one most important thing with these electrolytics is the polarity. This board luckily is marked, and the even nicer thing is the markings match the schematic and what's in there. Sometimes you'll see the boards have mislabels on them, or the schematics are backwards. So always look at what the polarity is when you take the old one out and put the new one in the exact same way. So we got it in, we soldered, we're snipping, and now I'll bring the camera to my side so you can see what I see over here. So I'm doing the next one here. As you can see, I'm just going around. Don't put this iron on any solder pad for too long. Alternate, go slow, just get a little bit each time, and the key is to not stay on there for too long. So better to bounce around and do, you can be on there for 5 seconds, but do it a second at a time, as opposed to just holding it on there for 5 seconds from the get-go. So we got all the solder off. I just pulled the cap out. Now we've got the new cap in. We'll just solder this in. The key with this is you just you want to heat the joint first, then apply the solder. Get it nice and hot. You want the solder to melt without actually touching the tip of the iron, just from the heat of the joint. So the tip's in there. It's got nice and hot. I'm just going to do it one more time just to make sure it's a good connection. We'll do the other side. Heat first, then apply the solder. Wait for it to really melt before you go trying to put a bunch on there. And you don't really need a lot. You just want a nice firm connection. Make sure there's no holes, but you also don't want a big circular glob. So we're going to come in, snip the leads as close as possible, and we'll move on to the next. So when I do these, I like to go one at a time. You'll see some people, they pull every single cap out of the board, and then they go back and put everything back in. To me, that takes forever, because you're constantly trying to look at the schematic or your photo or board diagram and figure out what cap went where. This way, if you've already picked out your replacements, you know what you're going to be putting there. You just can pull this thing out. You can match it up to the cap that you pulled and put it in, and then there's no question. Otherwise, you get mixed up. You'll be looking at the board diagram backwards or mirror reflection, and it's very easy to put the wrong thing in the wrong place. if you take them all out. If you go one at a time, it's a lot harder to make a mistake, especially if your board has the polarity marked on it and you're just very conscious about putting it in the right way. And then of course we'll go through one last time and check our work at the end before we ever even try to turn it on. I'm going to speed through some of this because it's kind of redundant and boring, but when I get to my other more preferred way of removing the cap, I'll slow it down and I'll go over what we're doing there. Alright, so now that we're to these smaller caps, this is the best way to take these out on these older boards. Way less chance of damaging. Just use your actual soldering iron, alternate back and forth, and on the other side basically you're just rocking the cap side to side, and there's no way you can heat the pad too much, but you're doing it just enough to inch it out little by little. And then you come in after with the desoldering sucker and just get that little bit of solder off the holes. But I have yet to damage a board doing it this way. With the big caps it's hard because the third leg really makes it not easy, especially with the bent legs. But with this thing, you literally just rack them side to side while you're alternating with the heat, and they'll pull right out of there. So I matched the capacitor. I saw which way I took it out, putting it in the exact same way here. Get the soldering iron, and like I said, just heat the pad and the joint first, and then you're gonna put the solder on once it melts, and just a little bit, just enough to close the gap and make a good connection. You don't want blobs, and you don't want it to be like gray. You want a nice shiny finish, as close to factory as you can get it. And we'll also go through and refresh all the old solder joints that we're not touching. I'll show you how we can reflow those, and the board will look like new again when we get done with it. Just to recap, my two biggest tips are: don't trash the board with too much heat. If you can get it out with your regular soldering iron, do that and just alternate back and forth. And don't get the polarity wrong. You'll see with the transistors, it's very easy to put stuff in backwards or wrong. I'll show you how to avoid that too with those, but I'm going to speed through the rest of these capacitors. It's kind of redundant like I said, but you can watch me solder the rest of this at 10 times speed, and we'll slow it back down when it's completely done. Alright, check it out. We got all the new caps in. Now what I'm going to do is I'm going to compare it to the photo that I took and just make sure that all the polarities are the same as they were before we started. So here's my original photo, and here is the new photo, and I've confirmed they're all the same. Alright, so now we're going to change out all the transistors. We've got these three on the heatsink, and there's some more back behind it. I'm going to start by just removing these screws from here, getting those screws out of the transistors, and then the two screws holding the heatsink in the bottom I'll take out, and that heatsink will just pull right out of there and give us some room to work. So we'll get this out, and then we'll see where we're at. Alright, so now we're just going to pull the heat sink out, and now we have much better access to the transistors here. So we're going to do the small ones first. I'm going to take one out, and then I'm going to show you how to make sure that you're putting in the right replacements, and also that you're putting them in the right way. So here you see we have the 2SC869 that came out first. Alright, so here's the most important thing about transistors and replacing them. This is the 2SC869, which we just took out. And this is the suggested replacement, 2690. You want to compare the numbers and just make sure, one, that it's actually an NPN. NPN, that's good. Then we got 160, 160, and 5. Here we've got 160, 40, and 5. So this is an upgrade. This is actually going to run a little bit cooler than what was in there originally. And then the other thing you got to be very mindful of is the pinout. So here you can see we got the 2SC869. You're looking at it front ways, like this. The base is on the bottom, collector in the middle, and emitter on top. You look at this one. Right, we go the same way. If you look at the picture, the bottom one is the emitter. So when you put this in, you have to put it in the right way. So it'll actually be backwards compared to how the original was in. So this has a nice little diagram on it. You can see the base points away, and then you got the collector and the emitter on the two other holes towards the resistor. So we're going to make sure we put these in the right way. We're going to take them out one at a time, check them with the real data sheets, and replace them all 8. We got 1, 2, 3, 4, 5, and then the 3 big ones that go on the heatsink. Alright, so I'm slowly but surely getting all the replacements in here. I'm going one by one, checking them just like I showed you on the computer. Taking one out, putting one in, double, triple, quadruple checking that it's the right type of transistor, NPN or PNP, and also that I have it oriented correctly per the board diagram. So we'll speed right through the rest of these transistor replacements, and then we'll get the heat sink back on and touch up the board and be ready to go here. Alright, so we got all the replacement transistors in. We are going to put some new thermal grease on the heatsink. This stuff makes all the difference with how much heat gets transferred. What was on there before was all dried up and barely anything left. So I'm going to put a healthy coating of the thermal grease on the heatsink and also on the side that touches the transistor. And we will get this back in and get those transistors screwed down, and then we'll go clean up the board. So everything's on. Now I'm just going to clean up the board. I'm going to put some flux on the stuff we didn't touch, take some of the old solder off, and then just reflow some new solder on all the joints. So I'll speed through this as well. You can see what I'm doing, even at quick speed. Just going to clean everything up and make it look good. Now we'll just go in and snip any excess leads that we might have missed. And last but not least, we'll get a toothbrush and some 90% alcohol, and we'll just clean off all the old flux and just get it looking nice and shiny again. Alright, and just like that, we're finishing up cleaning. And we can say that we are done with this power supply. And in the next video, we'll try it out on the dim bulb tester and check some voltages and maybe even power it up with the line voltage. If you're enjoying these series, make sure to subscribe so that you can keep up with the progress and follow along.